We're now going to look at suitable domains and restrictions on the domains. Domain is the input function, so that's numbers that you can input into the function. The range is the answers that you get out as a result of putting numbers into the domain. So domain is the input and range is the output. Now, in terms of restrictions on the domain, remember that two things that we can't have in maths is you can't divide by 0 and you can't get the square root of a negative number. So first one, we've got f of x is equal to 1 over x squared minus 4. G of x is equal to x plus 1. The question then says find f of g of x. Well, f of g of x is f of x plus 1. The f function tells me that whatever's in the bracket is on the denominator, write it down and square it, take away 4 with a 1 up top. So whatever's in the bracket, I write it down the denominator, square it, take away 4 with a 1 up top. So x plus 1 all squared, take away 4 with a 1 up top. I can then tidy up the denominator there. So that will be 1 over x squared plus 2x plus 1 minus 4, which can then be written as 1 over x squared plus 2x minus 3. Now the restriction on the domain there is we couldn't have numbers inputted into the function which will give us a denominator of 0. Therefore the denominator can't be 0. X squared plus 2x minus 3 is not allowed to be 0. So it cannot be equal to 0. Two numbers that multiply together to give minus 3, add together to give 2. That will be x plus 3 bracket x minus 1 cannot be equal to 0, which means x plus 3 cannot be equal to 0, x minus 1 cannot be equal to 0. So x cannot be minus 3 and x cannot be 1. Those are restrictions on the domain. Now, the terms restriction in the domain and suitable domain are really interchangeable. If minus 3 and 1 are restrictions on the domain, then that implies everything else is suitable. Example 2, f of x is equal to 1 over x plus 7. G of x is equal to x minus 2. Find f of g of x. Well, that will be f of x minus 2. So the f function tells me that whatever's in the bracket is on the denominator with this plus 7 with 1 up top. So that's that. I can then tidy up the denominator. And that will be 1 over x plus 5. The question then says any restrictions on the domain. So again, the denominator cannot be 0. X plus 5 cannot be 0, therefore x cannot be minus 5. That's the restriction on the domain. Okay, next question. I've got f of x equals 1 over x squared minus 1. G of x equals x plus 1. The question then says that h of x is equal to g of f of x. Find h of x. So the question also asked me to write it as a single fraction. So that's g of 1 over x squared minus 1. So the g function is whatever's in the bracket, write it down and add on 1. So whatever's in the bracket, write it down and add on 1. If I'm going to write this as a single fraction, then I can get a common denominator, so I can write 1 as anything divided by itself, which is 1. So the common denominator would be x squared minus 1, so I could write 1 as x squared minus 1 over x squared minus 1, given that anything divided by itself is 1, for example 5 over 5, or 6 over 6, or minus 3 over 3, all 1, so x squared minus 1 over x squared minus 1 is also 1. So I can then add these together. The 1 and the minus 1 will cancel out there and give me x squared up top, and down bottom I've got x squared minus 1. Question then says find a suitable domain. So the restriction on the domain is x squared minus 1 cannot be 0, since that's the denominator and the denominator cannot be 0. So I can then do a difference to squares. X plus 1 bracket x minus 1 cannot be 0, which means x plus 1 cannot be 0 and x minus 1 cannot be 0. Therefore, x cannot be minus 1 and x cannot be 1.